and costs. So we are in chapter 8. We have already drawn a project network, which in chapter 6, in chapter 7, we understood what managing risk is. So today we'll dive deep into resources and cost which are associated with a project. Resources and priorities. So project network time are not a schedule until resources have been assigned. So what is the significance of this statement? We have drawn a project network, but we assumed our resources are unlimited, which is in practical life or in the business world not really true. So when we try to make a network based on the resources available, that becomes a realistic network. The other thing is, like, we cannot really estimate a project, we cannot develop a budget for a project unless it is time phased. What does it mean? If there are two activities which require some resource, they will cost differently if they are to be executed at the same time compared to if they are executed in sequence. Maybe if they are executed parallelly, you might have to rent two machines, compared to if they are executed in sequence, you might use the same machine after the first activity is completed. So that's why it is said that a budget is, you cannot really make a budget to its true sense unless it is time phased, unless you do it based on a network. So these two are very much interlinked, the time network and the cost and the resource available. The process in which a project planning is done, we have divided the whole project into WBS, work breakdown structure, into activities. We can again drop down from level 0 to level 3, 4, whatever details you'd like to go. From there we'll draw a network which can be activity on network or activity on node. After that, we'll be going for the resource allocation. We'll do the resource and cost scheduling. So we will assign resources to each of those activities based on the network. And again, after all these are done, we'll make the master plan. And of course, we have to assess risk in each of these processes of project planning. There are two specific problems which we have to handle. One is in resource allocation, one is the resource smoothing, other is the resource constrained scheduling. If there are two activities which are to be executed, which in the network they can be done parallelly, but because of the resource constraint, it creates some difficulty to do them in the same time, because you don't have enough resources. So those activities which have got slack, you might push them back so that you get the critical activity done first, and then you do the activity which has got slack. So this is called resource smoothing. You try to smooth up the resources, so you don't use all your resources in one instance. Other is the resource constraint scheduling. When you make the schedule, you keep your available resources in mind. You cannot do it just on the time requirement. Then you might be doing some mistake. But again, we might have some time constraint. So based on the resources, you try to find the most optimum time. The technical or logical constraint. What is that? Activity B cannot be started unless and until you are done with activity A. This is a technical or logical constraint. We have physical constraints, activities that cannot occur in parallel because of some environment condition. So those are physical constraints. Then comes resource constraint. Logically they can be done parallelly, but because of some resource constraint, you cannot do that. So you have to do it in sequence. You can do it only when one activity is completed, then the resource can be moved from that activity to the next. Resource constraint can be because of people, for material and equipment. So this is intuitive. You don't have enough people to carry out two activities parallelly. Okay, you have to get done with one, then you have to start the other. It can be materials constraint. So you have trucks which are supplying raw material in a construction plant, and trucks come every day. So there is a constraint of the material which is available. So for that, you have to wait for one activity to be completed before you start the next. Or it can be equipment constraint. You have some drilling rigs, so two boreholes cannot be drilled at the same time. One has to be completed, then you have to move to the next. So those are some of the constraints which we'll be dealing with in this chapter. Business, you start the project, you do the groundwork or the basement, then you pour concrete, you put the frame on it, do the roofing, and it ends. So that is the logical or the technical constraint which determines the network. But the resource constraint is, say you can do purchasing, decoration, and the hiring of bands at the same time logically. But the problem is you don't have enough people to do that. The same person is doing the purchasing, he'll do the decoration, and he'll do the hire. So if that happens, we probably have to do these activities in sequence. So after the band hiring is completed, he will go for the decoration, and then he'll go for the purchasing. Classification of a scheduling problem using a priority matrix which will help determine the project is time or resource constraint. So there are some projects in which if it is delayed, there is a huge penalty. So that's a time constraint. There are projects where time is not that important, so it has got a resource constraint. So time constraint, time is fixed, resources are flexible. On the other hand, if the resources are fixed and the time is flexible, then you have to decide the project based on the available resources. Of assumptions. Again, assumptions are done to make our life simple. Splitting activities is not allowed. So if you start an activity, you have to complete it. You cannot take resources from that half-done activity and take it to some other activity. The level of resources used for an activity cannot be changed. So you have deployed 2 person in activity. When it's half done, you are moving 1 person from that to somewhere else. It's not done. The activities with the most lag poses the least risk. Okay. Reduction of flexibility does not increases risk. So